Hi, this video is about will the real AI engineers please stand up? How to identify real-world AI engineers for your company. And if you need help with this, you can contact us today. You can call the number here. I'll put it in the description, and I'll give you a free custom AI implementation roadmap. There'll also be a link in the description. So this is a picture of a robot M&M referencing the will the real M&M please stand up? I think that's what it's called. And also I shot a separate video about bad AI solution architecture. I highly recommend you watch that because that's key to understanding whether or not this a person really knows how to build modern, effective AI-powered solutions. So first of all, it's important to know that basically you can't have more than basically 1.5 years of experience being an AI engineer. And the reason for this is so it's August 2024, and I would think that basically the capabilities of LLMs starts really when GPT-4 came out. Now maybe you can count GPT 3.5, and there were definitely some people working with like GPT-3 and GPT-2 trying to make solutions. So there's a very, very small amount of people that were working with those, but like GPT-2 was so different as to be a completely different tool, and so I'm not sure even how applicable that is. So this by itself makes it incredibly challenging to figure out who has the real world experience, because part of this is not just about quantity of time, because there's just not that much time. You can't have somebody who has 12 years of AI engineering experience, at least not with modern LLMs. They just didn't exist. And machine learning engineering is not the same thing. There is overlap, and it definitely helps to know machine learning engineering, but there's a bit of a different framework to where machine learning engineers may or may not be able to be effective AI engineers. You know, this is a little bit like a race car driver. They don't necessarily have to know all the mechanical engineering. It helps a little bit to understand some of those fundamentals for sure, but they don't need to know all the ins and outs of designing things and how, you know, how different materials work with each other. Again, I think some of that does help, but there's some fundamentals that are really important and some that are just really super deep details that are not quite as important. And I will say that at our company we have multiple AI engineers, and probably the best, or definitely one of the best AI engineers we have is not a machine learning engineer. Now he is just generally a very good software developer, and so computer science is really important, and having that kind of software experience, you're not going to find somebody who has no software experience. At least I think it's very unlikely that they'll actually be able to be a good software engineer. But yes, one of the most important things is calling and handling inference on LLMs. So understanding kind of how inference works is more important than necessarily understanding like pre-training. Let's dig a little bit deeper into how to kind of spot a real AI engineer. So first of all, almost without fail, they should know Python. Most of the best libraries are in Python. Python is the language of processing data. There's just a whole bunch of reasons why they should know Python. I think this is the most important software language. Now, it is possible someone could done a lot of AI engineering with maybe JavaScript or some other very common language, but in general, I think that you probably want them to be able to be building in Python. Now, if they're a senior developer and they don't know Python, especially if they're a back-end developer, let's take back-end, greater than front-end. If they're a senior back-end developer, there's a pretty good chance they could pick up Python pretty quickly. I have a lot of experience coding in back-end languages, and I was able to pick up Python almost in a weekend, and especially with AI, it really made it very, very easy to be picked up. So it's not that they have to have it, it's just they need to at least be willing, and them not having it is a little bit suspicious to me that, you know, if they're calling themselves an AI engineer, and especially if they're saying that they have a lot of experience with it, a lot of the tools you're going to need to have used Python. And then this is a really simple question. If you're interviewing them, have you actually called OpenAI's API or Claude's API or Meta Llama's API in code? How have you actually done that? And have them explain what they did. Have they actually built, and this one's a little bit less talked about, foundational working building blocks with LLMs. So what does this mean? This means like creating, let's say, classes in Python that make it easier in the future to work with LLMs. So this is, when they go to build a solution for an LLM, do they build the building blocks that make it so that the next solution they build is that much easier? That to me is a really good sign, because that's going to be key to making sure that work is utilized even if you don't end up working on the solution. So there's tools like LangChain. I think there's something called Llama Index that kind of shortcut a lot of this stuff. And if their answer to calling things is, oh yeah, I just used LangChain and it was like 3 lines of code, well, that's not very helpful. I love the idea behind LangChain. I love what they're doing. They have a lot of things right, but when it comes to actually using them in real world solutions, I find it to be, you're really dependent on it. It's really hard to see what's going on underneath the surface, and there's a lot of decisions that they make for you that might not be right for your solution. So it's really easy to spin up a very simple, quick solution with LangChain and these kinds of tools, but it's very difficult, and ultimately it's more work than it's worth to actually kind of tune that and really make that your own. And then here's a really big one: not to use LLMs where it isn't needed. This is really critical because LLMs are slow, expensive, and unreliable in general. And so if you can solve it with classic coding, if you can solve it by, actually this process doesn't need LLMs, then, or at least I can break this process into 2 parts. 80% doesn't need LLMs and 20% does. That's good. That's what you want to see. I think also just kind of any data processing with code is incredibly helpful. And this one's, maybe this is just good for software development in general. This is something that kind of surprised me about working with software developers. There's very few that actually think creatively. And this is pretty important because a lot of the code is unwritten. A lot of the structure of what needs to be done is not, there's not really a good course for it. I'm sure that there are other AI engineering courses out there, but my guess is that the people who wrote those, when we look back 5 years from now, will feel pretty sheepish about how they basically got most of it wrong. And so it's not like you can know what's in front of you. You have to have somebody who sees the problems, thinks about the tools that they have, and builds something that's new. You can't just copy somebody else's code from 2 years ago and expect it to work from an AI engineer standpoint. This is new tracks. This is new ground that needs to be laid. And so being a creative thinker is really, really, really helpful here. And then there's prompt engineering specifically for software development. There's tons of information about prompt engineering, but most of it has to do with for ChatGPT or using the LLMs directly. There's a very different dynamic, and I think I'll shoot a video about this. There's a very different dynamic when you're trying to call LLMs and handle their responses within software. You need to have a much more reliable output, but then also there's a lot more preparing the data. I think you have to have a lot more structured input as well. And then again, a lot of times you want to actually pull the pieces of the solution apart and call LLMs much more often than what a lot of people think. In terms of the solution, you're probably looking at calling LLMs in an AI-powered solution. You're probably looking at calling LLMs many times within there, and maybe using different models. Maybe you fine-tune one for this specific purpose. Maybe there's something data you need to process, but you actually need to break it into 3 parts and do 3 different prompts, and then push those back together. Maybe that's a prompt in and of itself. And then there's all sorts of other work that needs to go in there, and that there's all prompt engineering in there. So somebody who has done that, who's actually figured out how to get a reliable output from prompts and fit that in a system, that's incredibly valuable. And then yes, I think what I would do to hire an AI engineer is, first of all, watch the video that I linked to below about the bad AI architecture. Ask them to just draw a picture of, come up with a very simple use case for your business or for anything, and ask them to draw a high-level architecture of how they would build that. And if the LLM is at the center and everything is kind of orbiting around that, then that's not good. And I think that they're still living in a different world that most people haven't really figured out yet. The real nerds that I've talked to who are building real-world solutions understand that the architecture is the other way around. use classic. You use LLMs as tool. The classic code uses LLMs as tools, and not the other way around. So if you would like a free custom AI implementation roadmap for your company, contact us today. You can call this number, or you can click the link below. Thank you very much. Have a great day. Bye.